Welcome to our video on quantum computing. In this video, we will explore what quantum computing is, and how a normal person can learn and understand it. What is quantum computing? Quantum computing is a type of computing that uses quantum mechanical phenomena, such as superposition and entanglement, to perform operations on data. In contrast, classical computing uses classical mechanics to perform operations on data. One of the key features of quantum computing is that it allows for the manipulation of bits, which are the quantum analog of classical bits. Bits can exist in a state of superposition, meaning they can represent both a 0 and a 1 simultaneously. This allows quantum computers to perform certain operations much faster than classical computers. Another key feature of quantum computing is entanglement. This is a phenomenon where two bits become connected in such a way that the state of one qubit depends on the state of the other, even when the bits are separated by a large distance. This allows quantum computers to perform certain operations that are impossible for classical computers. Want to learn and understand quantum computing? Start with the basics. It's important to have a good understanding of classical computing and the basics of quantum mechanics before diving into quantum computing. Learn the key concepts. 1. Bits 2. Superposition 3. Entanglement 4. Quantum gates. What are bits? A qubit is a system that can exist in a state of superposition. In simple terms, a qubit is like a light switch that can be in both the on and off position at the same time. This is different from classical bits, which are the basic units of information in classical computing, and can only exist in one of two states, 0 or 1. Because a qubit can exist in a superposition of states, it allows quantum computers to perform certain operations much faster than classical computers. For example, a classical computer would have to check each possible solution of a problem one at a time, while a quantum computer can check all of them at the same time. It's important to note that bits are not just theoretical. They have been physically built and implemented in different platforms such as superconducting circuits, trapped ions, and semiconductors. In summary, bits are the building blocks of quantum computing, and they are what allow quantum computers to perform certain operations that are not possible for classical computers. What is superposition? Superposition is a key concept in quantum mechanics, and it refers to the ability of a quantum mechanical system to exist in multiple states at the same time. This is different from classical mechanics, where a system can only exist in one state at a time. A simple way to think of superposition is like a coin flip, where the coin can be both heads and tails at the same time, before it lands on one side. In quantum mechanics, a qubit can exist in a superposition of both a 0 and a 1 state at the same time, until an observation is made. One of the most famous example of superposition is the Schrödinger's cat thought experiment, in which a cat is placed in a sealed box with a device that has a 50% chance of killing the cat. According to the laws of quantum mechanics, the cat is in a superposition of both alive and dead states until the box is opened and the state of the cat is observed. In summary, superposition is the ability of a quantum system to exist in multiple states at the same time, which allows quantum computers to perform certain operations much faster than classical computers. What is entanglement? Entanglement is a phenomenon where two or more quantum mechanical systems become connected in such a way that the state of one system depends on the state of the other, even when the systems are separated by a large distance. A simple way to think of entanglement is like two coins that are connected in some way that the state of one coin, heads or tails, will determine the state of the other coin. Even if you are far away from the other coin, you will know its state just by looking at the state of your coin. In quantum mechanics, two bits can become entangled, meaning that the state of one qubit will be dependent on the state of the other qubit, even if they are separated by a large distance. This allows quantum computers to perform certain operations that are impossible for classical computers. It is a key concept in quantum computing, because it enables quantum algorithms to perform certain tasks more efficiently than classical algorithms. It also enables quantum communication and quantum teleportation. In summary, entanglement is the phenomenon in quantum mechanics where two or more quantum systems are connected in such a way that the state of one system depends on the state of the other, even when they are separated by a large distance. It is a key concept in quantum computing and quantum information processing. What is quantum gates? Quantum gates are the basic building blocks of quantum computing, similar to how transistors are the basic building blocks of classical computing. They are used to manipulate the state of bits in a quantum computer. It is a unitary operation that is applied to one or more bits, and it changes the state of the bits. The most commonly used quantum gates are the X gate, the Y gate and the Z gate, which are used to change the state of a qubit from 0 to 1, or vice versa. Another important gate is the Atomar gate, which is used to put a qubit in a superposition of states, meaning it can exist in both 0 and 1 state at the same time. Additionally, 2-qubit gates are also used in quantum computing, such as the CNOT, controlled NOT, gate, which allows a qubit to control the state of another qubit. In summary, quantum gates are the building blocks of quantum computing. They are unitary operations that are applied to bits in order to manipulate their state, and they are used to perform a wide variety of quantum algorithms. They are the equivalent of the logic gates in classical computing.
They include the X, Y, Z, Atomar gates, and the CNOT gate among others.
Want to learn about quantum programming? Quantum programming is the process of creating and executing quantum algorithms on a quantum computer. It involves using a quantum programming language, such as QHash or OpenQASM, to write code that can manipulate the state of bits and perform operations on them. QHash, Q#, is a domain-specific programming language used for expressing quantum algorithms. It was developed by Microsoft and it is used to program quantum computers based on the topology of bits. It is similar to classical languages like C# and Python, and it provides a set of operations and types that are specific to quantum computing. OpenQASM, Open Quantum Assembly Language, is an open-source, intermediate representation quantum assembly language. It is designed to be used as a common language for describing quantum circuits, and it's used to describe quantum gates, measurements and other quantum operations. It is similar to classical assembly languages, and it is used to program a wide variety of quantum computers. Other ways of learning quantum computing. Join a quantum computing community. Join a quantum computing community such as the Quantum Computing Stack Exchange to ask questions and learn from experts in the field. Take an online course. There are many online resources available that can help you learn about quantum computing, such as Coursera and edX. Current applications of quantum mechanics. Currently, quantum mechanics is being used in a variety of fields and industries, although the technology is still in its early stages of development. Some examples of current applications of quantum mechanics include quantum cryptography. It is used to secure communications by transmitting keys through a quantum channel that cannot be copied or intercepted. Quantum simulation. It's used to simulate the behavior of complex quantum systems, such as the behavior of molecules and materials. Quantum metrology. It's used to improve the precision of measurements in fields such as sensing, imaging, and navigation. Quantum computing. It's used to perform computations that are intractable for classical computers, such as factoring large integers and searching unsorted databases. Quantum random number generation. It is used to generate truly random numbers, which can be used in applications such as encryption and simulations. Quantum error correction. It's used to protect quantum information from decoherence and other noise, which is critical for building large-scale quantum computers. Why to learn about quantum mechanics and how much impact it will have in future. Quantum mechanics has the potential to revolutionize a wide range of industries in the future. Some of the most promising areas for quantum computing include drug discovery. It can be used to simulate the behavior of complex chemical systems, which can aid in the discovery of new drugs. This can be done by simulating the interactions between different molecules and predicting how they will behave in the body. Financial modeling. It can be used to perform complex financial modeling, such as portfolio optimization and risk analysis. This can be done by simulating the behavior of financial markets and predicting how they will behave in the future. Machine learning. It can be used to speed up machine learning algorithms, such as neural networks. This can be done by using quantum algorithms to perform complex computations that would be intractable for classical computers. Cryptography. It can be used to break encryption codes that are currently considered unbreakable. This can have important implications for cybersecurity and national security. Artificial intelligence. It can improve the performance of AI algorithms and enable the creation of more powerful AI systems. It's important to note that quantum computing is still in its infancy and rapidly evolving field. It has the potential to revolutionize many industries. However, the potential for quantum computing is enormous and it is expected to have a major impact on many areas in the future. While it may seem intimidating at first, with the right resources and a willingness to learn, anyone can gain a basic understanding of quantum computing. Thank you for watching this video. If you have any further questions or would like to learn more about the topic, please let us know in the comments below. Be sure to subscribe to our channel for more videos about the latest technology and trends.